All right, well, welcome here to the June meetup. Come on in, folks. Let's grab a slice, grab a seat, grab a beverage. Come on in, folks. There's some more chairs over there on that side if you want to grab a chair. All right, so very first thing, we've been doing this for years. Who is hiring? Is anyone in the room currently hiring? We actually have someone hiring finally, and 2 people. All right, here's what you're going to do. You're going to stand up. You're going to say what you're hiring for, and I will repeat it because you're not mic'd up right now. So I saw your hand first. What are you hiring for? Wait, who you are, where do you work, what are you hiring?
My name is Ben Carlson. I work for a financial technology company called BDO1. We are a securitization analytics firm. We are hiring for analysts, looking for people with some entry to mid-level SQL experience, maybe some R or Python, with experience with data frame manipulation, and if you have a background in basic financial terminology, that'd be helpful.
All right.
2 open positions.
So what was the name of the firm again? DV01. Now, if you didn't catch all that, especially folks who are not here virtually, if you're here in person, go say hi after the meetup. If you're virtual, would you go to the Slack and post on the job postings channel?
Of course.
Yeah. And so this will be on the job postings channel, so anyone who's not here in person, you can apply there. If you are in person, go say hi. This is the way it's worked for the past 15 years. I saw another hand over here. Yes?
Hey, I'm Sean. I work at the Central Park Conservancy, and we're hiring for an assistant manager of data systems on my team. It's very much an operations-focused role, so sort of a jack of all trades in terms of analytics, but very much on like a decision support or like day-to-day operations lens. Database management, spatial analysis, and GIS is a big part of the position. So anyone with skills or interest in GIS definitely is a great fit for me. So I'll be here.
Great.
Thanks.
So that's the Central Park Conservancy. Again, if you're in person, go say hi. If you're not in person, would you post it on the Slack and the job postings channel?
I'll join and I'll post it.
Great. For those of you that don't know, we have a Slack. If you go to nyhackr.org, there's a link on the top. If you're on the desktop, it's on the top right. If you're on mobile, you hit the hamburger. And the Slack is nyhackr.slack.com. And there's a channel called Job Postings where people post jobs, and you can go find jobs you're looking to apply to. Are you hiring too?
Yeah, hi, I'm Armstrong. I work at Bank of America, Global Markets Risk, Market Data section. So we're hiring, and we're looking for people with a certain amount of financial experience in market data. And we work all day with time series.
Cool. So Bank of America, can you post it on the Slack?
Sure.
Cool. Paul, someone from BAML is here hiring. I expect more out of you next time. He works on the ML side. Yeah, for years. All right, so everyone go apply for those jobs. Anyone else hiring? This is the best we've had in the past few months. The economy's turning around. Love to see it. All right, next up, we've been doing this for 13 years. The pizza. This time, it is from Arturo's, hand-picked up artisanally by Mike and George, because the delivery did not come, so they walked over there and got it themselves. So if everyone can go on their phones to bit.ly/pizzapoll, all lowercase, and go and vote on the pizza, rank it, tell us how you liked it, approval or non-approval, tell us how it was. We've been collecting the data for 13 years roughly of monthly pizza data, some repeats, some not, so sort of panel data with some repeats. And we have had people analyze this data. If you want to see it, it is live on nyhackr.org as a bar chart, but also the data feed is available as a PHP, as a JSON feed. If you go to, I believe, jaredlander.com/data/pizzapoll.php, I think that's the address, it's available as live JSON. As you vote, the JSON updates. It is highly available data. So please go there. You're voting on Arturo's. Let us know how it is. We've been tracking this for a very long time, and we would like to keep tracking this. It's one of the hallmarks of our meetup group. So again, thank you to Mike and George for actually going out there and getting the pizza physically. Yeah. If you're watching this virtually and you didn't join us for pizza because you're not here, go in the chat and let us know what you're eating. It could be pizza or it could be anything else. Let us know. So how to chat with us. If you're virtual, 2 ways to chat. You can go to the YouTube channel of what you're watching right now and chat in the chat right away. Or you can go to that Slack we've mentioned, and if you're not a member, go to nyhackr.org, click on the Slack button, and join there, and there's a channel called Monthly Meetup Chat. Go in there to talk about the meetup. Which reminds me, if you have questions for the speaker, if you're in the room, you could ask questions personally, right? But if you're virtual, if you ask the question in one of those 2 channels, I will relay the question to the speaker, all right? So again, if you're virtual and you want to tell us what you're eating, or you want to ask a question, go to the monthly meetup chat of the Slack, or ask it right on YouTube. All right, a few other announcements. There is another meetup group, which is, they have a meetup coming up that apparently people will like in this group called Papers We Love. Is that the right name? Papers We Love? They are meeting, when are they meeting?
Thursday.
This Thursday.
Thursday, 6:30 at Datadog.
At Datadog. Can they find it at meetup.com?
Absolutely.
All right, meetup.com. They're discussing the All You Need Is Attention paper. Is that the name of it? No.
Attention is all you need.
Attention is, where's the speaker? Hey! All right. You're giving that talk. All right, so Thursday, go see him give that talk. We just doubled your turnout. Attention is all you need, right? I keep forgetting the name. All right, and you're getting plenty of attention right now. All right. It is a seminal paper. Actually, one of the authors on it lived in a house together, I think with my wife and a whole bunch of other Googlers. They all lived in a house together. She just found out he wrote that paper like 2 weeks ago. Right. All right. So, give an excellent talk. We're counting on it. All right. In October, we have the R in Government Conference, the R and Friends in Government Conference. It's called R in Government, but it's R and Friends. There will be a Python talk. There'll definitely be SQL talks. Might be a Stan talk or a Bayesian talk, or it might just be a database talk or whatever. Just like this meetup, it's R and Friends. If you want to learn more, you can go to rstats.ai/gov. And if you want to sign up for a ticket, you can use code nyhackr for a 20% discount. I'm not sure it actually went live yet. We announced save the date. I'm not sure you can buy tickets yet. But if you can buy tickets, you can get one. The speaker list is going to go up soon. We have a great lineup of speakers. It's going to be a fun time. It's just like the New York R conference we just had, but focused on government. That could be federal, state, local. It could be NGO. It could be nonprofit, public sector. We've actually had a previous speaker here, right? So, and actually over here too, right? So and over here, we have a lot of previous speakers there. All right. So it's a really good conference. It's like this meetup group, but focus and for 2 days in a row. Unlike the New York one, it's at a university, so there are no booze, but you know what? We'll go out afterwards. Yeah, so come to that. It's going to be a fun time. We really enjoy that. Speaking of the conference, the videos from the New York R conference just went live last week. If you go to rstats.ai and click on the videos link, you can find the videos we just posted and the past 10 years worth of videos and the past 6 years of RGov. It's a real good treasure trove of content to find anything you want to learn about. And also at nyhackr.org, if you click on past talks, we have 15 years of talks from this meetup. All right? Not all of them were videoed, but we have videos for all the ones that were caught on video, and we have slideshows for just about every single talk for the past 15 years. We actually celebrated the 15th anniversary of the meetup group back in April. And I noticed today, for the pizza poll, today is the 100th pizza poll we've done. Yeah. Yeah. I tell you, we take our pizza very seriously, right? We love pizza here. It's the best pizza city in the world. I'm hoping everyone in the Chicago meetup are listening to me right now. And the New Haven meetup, Paul. Yeah. All right, and we actually have the next few months planned out. We have meetups planned out going through October, all right? And possibly even November as of today, right? So we have it really planned out really well. I'm actually just going to check to see if I could give you the dates. I don't know if I have them on the top of my head. Does anyone give them to me? All right. July 30th is Kyle Barron talking about geospatial visualization and on the Python side and in general. Then Dorota, I'm going to butcher some of these last names. Dorota is talking about the janitor package. Dorota, who's the head of Our Ladies, is giving a talk about the janitor package. September we have planned. I think that might be the MTA giving a talk about how they do data. And October is going to be a joint talk with, how do you pronounce it? NYACOR giving a joint talk about political stuff. And November could be a talk by our very own George. So we have this thing planned out. They will be announced as we go, but we're very excited about having so much planned out in advance. It makes life really easy. And if you're in this room and you want to give a talk, or you're in this room and you want to volunteer your friend to give a talk, just come up to me and say, hey, you want to give a talk or you have a friend. December, all right, cool. And if anyone else wants to give a talk in January, we're taking ideas here, all right? Cool. Good to see everyone is excited for that. And a big thank you to NYU. They've been hosting us consistently for like at least a year now. It makes such a difference. And when I say NYU, I mean specifically George. He's been the reason we have this room and everything happening. So a big round for George. He's looking at me like, no, give NYU the credit. But thank you, George. It's really helped us a lot. So seriously, thank you very much. It's also his projector too, and his screen. All right, with that, I am very excited to have the June meetup kick off. Our speaker is actually someone who's hosted us at his old company many, 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 many times, and now finally is giving a talk after all this time. So everyone, please welcome Michael. Everyone, please welcome Michael. I just call him Mike. Welcome, Michael.
I've been coming to this meetup since I think I said 2016 or something. I put it in here. Long-time listener, first-time caller. So it's a really honor to be here speaking to everybody. I titled this talk Time Series Databases for Mere Mortals because I am a mere mortal. I'm not an expert in database management systems. I think I'm okay at it, but I'm not a core contributor. I'm giving this is sort of something that I've been working on at work for the better part of a year or two. So I'm giving this talk to myself a year ago. So if you have any really, really deep expert questions, you can talk to Dan, my coworker. So I'm assuming that you have pretty much no prior experience. We're going to start pretty simple. And if you are a really deep time series expert, I hope that we have some good nuggets here that you can also take away. I have no conflict of interest or financial stake. I'm going to talk about TimescaleDB. I don't get paid by TimescaleDB. TimescaleDB, if you're listening and you want to change that, give me a call. A little bit about me. I work on trading data at a place called Peak6 Capital Management. We're primarily an options trading firm. I tell you that because it will help contextualize where I'm coming from with this talk. I teach an ML course at Yeshiva University, and I previously worked in healthcare. It's good to see some prior coworkers here. Thanks for coming. And yeah, I've been coming to this meetup for a long time. So, all right. Let's start by defining the problem. What is a time series? And I apologize. My style is very, I don't like to hear myself talk, so I'm going to call on people. If you had to define a time series, how would you define a time series? I feel like it's one of those things like, you know it if you see it, but how do you define it? Autocorrelation. Okay. Yeah. Anything else?
Repeated observations in space, in the same space.
Yeah, or a repeated observation in the same space or over time. So yeah, I think about it as something that is like sampled consistently, right? So, I mean, you could have cheated and looked, right? It's sampled consistently. So something that you're sampling every millisecond, second, hour, whatever, but it's coming at a sort of regular interval. Generally, it's append only. And I say generally, obviously there are caveats there, but I think that's important for sort of timescale databases, and we can talk about why that is a little bit later. But if you have a use case where you're constantly sort of going back and fixing something up and rewriting, like this may not be the use case for you. I would say that it's something that approximates a continuous value. So what do I mean by that? I think we're us like engineers and data people, we like to get like real deep in the weeds and mad about things. So when you zoom in really, really closely to almost anything, right? A series is a series of discrete events, right? And we are, for example, like we'll talk about stocks or something, right? As a series of trades, and we are sort of representing that as a time series as if it's continuous. There are obviously some things that are actually continuous, right? Like you can, there is always a temperature, right? But even a temperature, right? There is some sampling frequency, right? You have a sensor. It may be listening, 1,000 times a second, right? It may be 1,000,000 times a second, whatever. But at some point, there's an event that is representing, you're taking like some continuous data and you're doing some sample over it. So I think that if your data can be, if you can think of it as being continuous, right? There are many. You can think of many things as being time series. So not just sort of temperature, right? But things that are like here's an example to make this concrete. So thinking about financial time series, let's say, for example, that this is a stock print, right? So a print is an actual trade that occurs in the market, meaning there's, two parties have come together, they've decided to transact at a certain price, okay? So we tend to think of stock price as being something continuous, but really, it's just a bunch of events, right? So, these two, events happened, and we're taking these sampling frequencies over these, let's say, where these vertical bars are. Let's say that this is, I don't know, 1 second. I don't know, it doesn't matter, right? So these two trades have happened, right? And then there's, and then another trade happens over here, and then there are a bunch of trades here, and then there's prices move around here, right? And we can sample this. We can represent this as a time series. So we're saying, let's think about at each time stamp, or at each sampling period, we can look and say, one way to think about this is, what is the last price I know? Like, as of this time, what is the last stock price? So, therefore, right, you would have like this is your print was here at where was gray is the color, gray, and then the green point being, that was at the time of when I'm taking the measurement, that was the last thing I knew, right? Then nothing happened for a second, so again, that price repeats. And what the caveat here is when there is some sort of you have to think about how you're sampling because, right? If you look at this, you're actually going to miss the high. So if that's something that maybe that's the high of the day, and maybe that's something that we care about, right? So you have to think a little bit about how you're sampling and what that means. But this is where the art comes in. This is why we get paid the big bucks here, right? All right. So now that we know what a time series is, let me talk to you a little bit about how I got involved in this and why I came to get involved in Timescale. So we were working on a project. I'm not going to get into like details, but you can imagine that there are many thousands of time series that we are interested in. We're talking about like dozens of terabytes, so big but not like huge. And we wanted to support both researchers, right, people who are looking over longer time periods or who may not know exactly what they're looking for, who want to sort of explore, and applications that care about latency and getting a reasonable response time from their database. And we support user-defined time series. So a user can decide, I have this time series, this is something I want to record, or this is something that I have collected, and I want to store it and be able to query it back later. So we have to be pretty flexible in what we can allow. So what did we end up doing? We chose TimescaleDB. TimescaleDB is pretty cool. It's open source. It's one of those projects that's like pretty fully open source and has a managed tier where you get support and management if that's something you want. I found that they're pretty good to work with. Their documentation's phenomenal. There's a really, really robust community. So it's a pretty good example of how to do open source. I think one thing that's really, really important and I think can't be understated enough is that it's a Postgres extension. So we all know Postgres. We know how to manage Postgres. We like Postgres. And this is important, all of our other data often lives in some sort of relational, it could be Postgres, right? So we have other relational data that we care about alongside the time series. So if you're in a sort of, we're not going to talk, dump on anyone else, but if you're in another database, time series database, where your time series data lives completely separate from your reference data or whatever other data you have, you're going to have to figure out how to get out of one and into the other. And here you have your data fully on the same host, right? Beautiful. It has full SQL support. We're going to show you what this looks like, but it is just full normal Postgres SQL with some nice time series functions on top of it. And you're going to see you get, they bring sort of columnar storage to Postgres. You get really nice compression. We'll talk about some of the other features, but it's an interesting project. So what did we get by going here? I'm going to lead with the sales pitch. I'm not a salesman, but we found that compared to our benchmark, which was doing an aggregation over a number of securities over a period of time, we were able to improve. It's a sort of the benchmark is a large distributed sort of like, you could think of like a MapReduce type of workflow. We were able to make this query 1,000 times faster by moving it into Postgres, into Timescale. We also saved 95% of our disk space. So it compressed really nicely. So I mean, that's a great sales pitch, right? Less storage and faster. I mean, Timescale, remember, hook me up. So I'm going to talk a little bit about some of the fundamental building blocks of Timescale, and then we'll jump into the demo stuff. We won't bore you with this. All right. So the fundamental building blocks of Timescale, I want you to think about hypertables and continuous aggregates. Hypertables being what you could think of as a table, right, in sort of normal SQL table parlance. What it actually is a bunch of tables which are chunked up underneath, and Timescale manages all the administration of those underlying tables. And you get this nice interface. It looks, it feels, it queries, runs just like a normal table. And Timescale hides a lot of the magic under the hood. But hypertable is part one. On top of hypertables, you build continuous aggregates. So continuous aggregate, we're going to talk about that, but you can think of that as like a view or a materialized view. That is a view that lives on top of your data and does some sort of aggregation on top of your hypertable. How do you create a hypertable? Well, like I said, this is vanilla SQL, right, with some additional functions. So creating a hypertable is as simple as calling select create hypertable, telling it what table you want to make a hypertable, and tell it what your time series column is. And time series will Timescale takes time. Timescale will handle the rest of it for you. All the chunking, all the partitioning. You can obviously tweak it yourself, but to get started is as simple as that. And like I said, this table will act just like any other Postgres table. So you can join it with other tables. It's great. All right. All right, next question. Who can define the difference for me? What's the difference between a view and a materialized view? Yeah.
Materialized view is actually persisted on your disk.
Yeah, so a materialized view is persisted, whereas a view is?
No, I mean, it's
No.
actually usually a query.
Yeah, yeah.
It's a query.
Yeah, so a view you can, for those who are not familiar, a view you can think of as, it's almost like a variable name, right? Where your view represents just a query, right? When I run, select from, I don't know, top employees or something, I would get, it would execute the query that would, select from employees table where, blah, 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 right? That would be, so your view is literally just executing a SQL query, whereas your materialized view, like you said, is actually materializing that data to disk, meaning it's storing off, it's pre-computing some of that, so it's stored off ahead of time. All right, what is, why wouldn't you always use one or the other?
Materialized view we use for performance if you need to be able to, if you don't want to wait for the execution of the view.
Yeah, so a materialized view, like you said, you've pre-computed something, you've stored it to a table, it's sort of, you think of it like it's cached, right? It's pre-computed. So we don't have to wait for this query to execute every single time. What's the downside?
You need additional storage space or memory.
You need, well, yeah, you need disk.
And you have to, anytime you're modifying the tables that feed into the materialized view, it will update.
Exactly. So every time you, he nailed it, so I'll repeat. Every time the underlying tables or the underlying data in the query that has gone into the materialized view updates, you need to run a refresh on the materialized view, right? It has no concept. It's not live. It doesn't know that anything's updated. So you have to run a periodic refresh. Or if you want to get the freshest data, you have to run a refresh and then execute your materialized view. A continuous aggregate is the best of both worlds, okay? So it's essentially a materialized view unioned with an actual view, right? So when you define a continuous aggregate, you will define it just like you would any materialized view, and you'll see what it looks like. And under the hood, Postgres will know, Timescale will know, how to translate that continuous aggregate into this unioned view. And it will know how to run it has a job scheduler built in, which we'll talk about, under the hood. So let's say your materialized view has the data from 9 a.m. this morning to 6 p.m. today. And I want to run, and I'm streaming data into this hyper table. So the materialized view only knows about data until 6 p.m. Postgres will know, or the Timescale will know, all right, this materialized view is fresh as of 6 p.m., but now that I query it at 7:30, 7:27, right, I'm going to have to go to the view to get the most recent data, and then I'm going to union it together. So it's this really nice abstraction where you get the performance of a materialized view with the flexibility and the live updating view. It also handles scheduling internally. So like you said, a materialized view would you need to have a way to refresh it, right? You need to have a job or something that would go in and refresh the materialized view. And Timescale handles all that for you. It has a scheduler in the back. It takes care of it. Set it and forget it. Magic. This same scheduler can handle not only the continuous aggregates, but also periodic compression and your retention policies. So let's say, I only want to keep data within the last 6 months or something. I can tell it, I'm only interested in data in my underlying table in 6 months, and I want my continuous aggregates to stay for, years, right? So it will just, after 6 months, dump the data in the underlying hypertable, and the materialized view will persist the data as long as you want it. Adding policies, again, pattern, just SQL, right? So to add a compression policy is as simple as add a compression policy. Tell it what you want it to compress on, how frequently you want it to compress, set it and forget it. Beautiful. A couple of things. This is a little bit in the weeds. So if this is not interesting to you, take a nap, and I'll wake you up in a minute. But I think it's helpful to understand sort of how the compression works, because it makes a lot of this make more sense. So generally, right, Postgres is a row store. So you can think of something like an Apple stock price. Let's say every row is an instance of an Apple stock price, or a symbol stock price, so it's Apple or NVIDIA, whatever, in this situation. And then when I compress it, so this is where we talk about getting a columnar store and in Postgres. So it compresses those into columns, which are stored within a row in Postgres, which means that you get super, super efficient queries from that, and you'll see you get, we can use some compression tricks. So here are the ones that are built in to Postgres. They're not many. They're pretty simple. We're not going to go into tons of detail, but there are a few, kind of simple tricks that work really, really well, right? So for example, remember, time series data is nice in that we know it comes pretty frequently. It comes regularly. So we know something about the data. We know something about the character of the data. We know that, like you said, it's autocorrelated. So whatever happened is related to the later timestamps. So like, the chance of having, it's very unlikely that you have huge swings in your time series data from one step to another generally, right? So, and your values are similar from one step to another. So you can do things like delta encoding, where if it's an integer, you say, you store the first value, and then all you have to store is the changes from one value to the next, right? You don't have to store the entire number, right? And then you can obviously compact that with some CS trickery, right? You can do run length encoding, right? So you could say, let's say you record temperature. How often does temperature change, right? It's going to be, I don't know what it is. Like feels like 95 degrees, 95 degrees, 95 degrees, 95 degrees, 95 degrees, 95 degrees, 96 degrees, 96 degrees, 96 degrees. So I can say, right? We have 100 instances of 95 degrees, and then we have 8 instances of 96 degrees, and it compresses beautifully. We can do dictionary compression, where we can say, every time I see Apple, right, I'm going to call that 1, and every time I see NVIDIA, we're going to call that 2. So instead of having to store this whole string, we can compact that down nicely. And for floats, we use a gorilla compression algorithm, which is thanks to our friends at Facebook, or Meta, where you save the first value, and then you take the XOR, right, of the next values. And so you don't have to save this giant 64-bit float value, right? You can just save much less data on each subsequent time step. Cool. All right, the almost last, really nice feature is we have built-in time functions. So what does that mean? So we have, first of all, a time bucket. So that allows us to, and I'll show you how these work, but that will allow you to do things like, I want to create a 10-minute bucket, and I want to do some aggregation, an average over a 10-minute bucket or a 1-hour bucket. So you can just simply define time bucket, and it knows how to group your data and how to do all the timestamp math. You can do things like get the first value in the bucket, get the last value in the bucket, get the max, get the open, get the close, get the average, right? It has a timescale toolkit, which is sort of another library, where you get lots of much more complicated aggregations. So you have like time-weighted calculations. You have gap-filling algorithms. You have, oh, I wrote them here. You have a candlestick aggregation for time series for financial data specifically. So it's a very rich ecosystem with lots of built-in functions. All right, enough of me blabbing. Let's show you some code. If this is too small, give me a shout. All right, we'll see if we can make it. Hold on, let's make this bigger. All right, so the first thing we're going to do is set up tables. So the first table we're going to make is stock prices. This is data I downloaded, not from work. All right. So we've created that. Did we create that? We did. OK. So now we have tables, right? These are like normal old Postgres tables, right? Select all from stock prices, right? That is like obvious. Oh, OK, data's in there already. Phenomenal. We're going to make this a hyper table. Oh, man, let's delete it. That's not fun. I'm sorry. I thought I cleaned up. Yeah, it's gone. All right. Stock prices already exist. Lies. All right. All right, whatever. Oh, I have to cascade. Yeah, I'm sure. Don't worry about it. Yeah, OK, cool. Sorry about that. All right. Do it live. All right. It's unhappy with me. Yeah, that exists. I know that. OK. It's a hypertable. I don't know. What do you want from me? OK, fine. Let's see if it has data in it. That would save us the step of loading data. I don't know the shortcuts on this computer. All right, there we go. Yes, it has data. Fine. I assume it has indexes. OK, so let's pretend we did that magic. It's like cooking show. So, right, we would create indexes just like a normal table. We'd index our companies table. Oh, the companies table. So the stock prices table we showed you. Stock prices. So that is a table of stock prices, right? So I'll show you what this looks like. Can you see this? Right? Yeah, so it's timestamps and, all right, timestamps, right, symbols, and prices, OK? And then we have a companies table where we're going to have just the company name, but no, we don't have a companies table. We're going to add data to the companies table. Hold on 1 second. We're going to do magic. We're going to OK, now we have data in the companies table. And the companies table is going to be, yeah, just, OK, like names and you know, you can use your imagination and figure out, and this could be other things other than just their name and their symbol, right? The point here is that we can have all sorts of other data, right? We can have fundamental data. We can have whatever. Anything that you may want to include in your model. It already lives elsewhere in Postgres, and we get to use timescale just like any other Postgres table, right? This will join and tell us that it has, right? Here are, you know, it joins, voila, right? A hypertable and a normal table. Thank you. Magic. OK. All right, so let's look at some of the internals for you nerds. So you see, all right, you know, this is the the underscore name. So right, we're not really supposed to look at these, but we like to mess around. So this is sort of right there internal tables. So you know, don't write queries against them. They could move. They could break them. Right, this is theirs. But I think it's helpful to understand sort of how this works. So we look at our hyper table called stock prices, and it is always prefixed with hyper 18. So if we look, right, hyper 18 has a bunch of chunks under it, right? So this chunk is all the May 1st data, right? Let's look at, I don't know, is there 61? All right, 61 is the 30th data, right? April 30th. So because it knows how to chunk up the data, and it's doing that under the hood. These are the tables that they're OK with us looking at. So these are in the timescale information schema tables. We look at hypertables, and we get some information about, here are the tables that we have, right? Here's a stock prices table. Here are the number of dimensions. It's got 20 chunks. It's got compression enabled. No, not yet. All right, whatever. And then here's some information about all of the chunks underneath, right? Right. So we know here's the primary dimension, right? And we can look up like where the range starts and ends. So this is some useful stuff, right? If it has compression enabled. I really want to disable that. Let's try this one more time. I like really, really mean it. I did. Do you still exist? You do. All right. Whatever. Sorry. OK, cool. Let's look at compression. OK, So compression is already enabled, but if you would bear with me for a second, pretend that it's not here. Let's look at prices. Was it the other one? What was it called? Stocks. Okay. This table, I don't think I've played with. I was playing with it before. All right. Yeah, that's pretty small also. Okay. You can look at the size of the table. You can turn on compression like so by just altering the table. This does not actually do the compression. This just tells it this is how I want to compress. Now, this is a little bit important. This is something to mention. This tells it how the time series is ordered, right? This is the order by, so it's ordered by time. And then this is segment by. So if you don't set segment by is not required. But if you don't set segment by, it's just going to order by time. So remember when we saw that slide where we had, I don't have to describe it to you. We can look at it. Remember this guy, how it was segmented here by symbol? That's because I told it that that's a segment. If I don't segment it by symbol, this would also be a row, and then you would just end up with like ordering purely by time. And then if I wanted, if I wanted to then query by symbol, I would have to then filter down to symbol in another step. So this is where understanding how the query patterns, how your data is going to be used, how it's, that will sort of inform how you set up your data model. Because, right, if I know I'm going to want to, look at, symbol by symbol, I can add a segmentation by symbol, right? Maybe there's something else that I care about. I don't know. Exchange, right? Maybe I want to look at Apple and how it trades on a certain exchange versus other exchanges, right? So we could add other segments, right? Great. All right, back to this guy. All right. So we can tell it I want to compress a specific chunk, right? It's already compressed, so this won't be very impressive. But you can call compressed chunk on an individual chunk, or that seems like a waste of time. You can set it and forget it, add a compression policy, tell it, this is the table that I want to add compression to, right? And how frequently I want it to compress, and voila, Timescale will take care of that for you. All right. And we can see some compression settings here, some nice other things. All right, we'll move on. OK, setting up retention. So let's say, like we said, we don't want to store the raw stock prints, for after 6 months, right? Like individual observations, right? I mean, this is sort of already summarized, but you can imagine that this could be just every single event, and maybe that's too much to store. So maybe after 6 months, I'd say, yeah, I don't care about that. We're gonna drop it after 6 months. So I can set up a retention policy, tell it this is what I want to drop, and after 6 months, I want you to drop it, or after a day, or after 4 years. I don't know. Cool. All right, this is where it gets fun. So remember I said that Timescale comes with some built-in time series specific functions. So this is time bucket, right? This knows, remember this hypertable is, let's see. Oh, this is a different one. All right, let's look at what this underlying table looks like so you can see the magic. All right, so we see, this is like 830, 833, 838, 840, 840, right? So, they come periodically, okay? But let's say I want to bucket these by 10-minute buckets, and I want to do like an OHLC. So, or maybe I want the average price, I want the max price within that bucket, the min price, and I want the first price. I don't know. This is a strange query, but it's fine. So per symbol, I'm going to end up with 10-minute buckets. So here's 8, 810, 820, 830, and the average price within the bucket, the max price, the min price, the first price. Ta-da. And there are lots of these things. So now once you have a query that you like, right? Let's say, hey, I like this query. I want to, this is something that, my analysts, my traders are going to want to look at frequently. So I'm going to make this a continuous aggregate, okay? So like we said, vanilla SQL, right? It's going to look just like, let's see if this already exists. So what do I do? So that exists. Anyway, I'll make it another one, 2. Ta-da. All right. So this will create a materialized view, right? And I'm creating this with no data. I just wanted to set up, what the view should look like. And then I'll add a policy to it. I'm going to say, I want this to refresh. I want it to start refreshing a month ago, and I want it to finish, yesterday, and I want it to run every hour. Okay? So I set that up. I run, and now, da-da-da. What was it called? CAG OHLC. 1 minute, 2. Ta-da. All right. So this is all very impressive. And like I said, this is what's going to happen here if stocks are prices are continuing to change. And I look at this now, and then I query it again now, and I query it again now. Will this continue to change, or what? What's going to happen? Oh, so let's say like stock market's open, prices are changing. I have some live dashboard or something that's plotting the prices live, and I'm polling this query, and I'm plotting it, or I want to plot it now. Will this I've run this policy, right? It's put data into this continuous aggregate. Will this get the most recent value or no? Like, will this be up to date?
Wait an hour.
Huh?
Wait for an hour.
I have to wait for the next time bucket to end? Or the next hour? Huh? Oh, no, I have to wait for an hour? No. So this is the magic, right? A normal materialized view, you would have to wait for an hour because we have to wait for the refresh to happen. These are special materialized views. These are continuous aggregates, right? We know that because it says with TimescaleDB continuous, snuck that in there. And so what this is doing is this is creating under the hood, if we look at we can look at the view definition. Let's see if I can figure out how to find it. If we look at the view definition, we'll see that this is actually under the hood a materialized view that refreshes every hour. And the same view, like the same query, union together. So it will get the performance of a materialized view where available, but we'll get the freshness of the live query when I query it. So
upstream, it can tell between the old records and the new records?
Yeah, you'll see what it does is it knows how fresh the materialized view is, and it will say, okay, up until the end of the materialized view, give me data from the materialized view, and then from the end of the materialized view and on, give me live data from the underlying table. Let's see if we can find it here.
So if you have a 1 hour interval,
Yeah.
what's an hour it's going to take all the data that was being accessed by the view and put it in the materialized view. So you're going to have a change in performance over the course of every hour.
Yeah. So you're saying your query may slow down over the course of the hour if you have a lot of data in that view? Potentially. Yeah. I mean, that's where we have to wear our architecture hats and know sort of how things are going to be queried and know what the underlying data structure is and tune our queries and tune our continuous aggregates accordingly. I said an hour. That's sort of like the, I don't know, just arbitrarily chose that. Right? I could have it refresh every minute. I could have it refresh every second. I could have it refresh every day. Right? I can choose that interval. That's up to me. Let me see. Can I see the view? View the view? This is not it. All right. Whatever. You'll trust me that under the hood it's cool. I have to find it. All right. I'm not a big dbeaver user. I apologize. This is not work stuff. OK. Cool. Let's do something crazy, right? We can, let's say, create another. Let's say you'll say, hey, Mike, Michael, this is all great, but 1 minute's too much. I want to know, let's say, 1 hour, OK? And I want my interval to be 1 hour. But like, we have this minute data already available to us. Why should we make it go to the underlying hypertable? So we can actually build our materialized view off of this materialized view, right? And we just have to change the references to time, to TS, because that's what it's called in the materialized view. And if I didn't miss one, price, because it's called the max high, the min low, the first open, and the last close, right?
Is it going to build off of the materialized view, or is it going to build off of the continuous aggregate?
It's going to be sorry, the continuous aggregate. You're right. I said materialized view. I was incorrect. It's going to build off the continuous aggregate, and must contain a valid time bucket function. It has one. Why are you yelling at me? We know minutes worked. I don't know. Why are you angry with me? I don't know. All right. This is what happens when you do live demos. Why does this not work? Let's include a valid time bucket function. I think my context is wrong. Do you know I'm here?
Is that to be singular R?
No. No, it doesn't. I don't know. Why are we not happy? All right, well, we'll pretend that worked. You go, ta-da, manage. All right. I think I've messed my context up completely. Anyway, let's see what happens if we just open a new window. It's like it doesn't recognize timescales there. I don't know. This is odd. Whatever. Next. So our, and you'll see that we can also treat this materialized view like we would, we need 1 minute. Let's join it to company. So like we said, one of the beautiful things is that we are already on a relational database that knows things about our company. So we can join and get, here it's now we get Apple, the name from the company table, and all of the other interesting data that we want to model. Cool.
Will your materialized views inherit the data retention you find in the continuous aggregate?
Will the second one that I built off of?
Yeah.
No. Meaning, so I would set a new policy for that object. Yeah, important to keep in mind, though, is this is going in the weeds a little bit, but if you're, remember we set this policy window to go, where do we set it? Right, we set this policy here. So I said my start offset is a month. If my, let's say my retention on my underlying data is 2 days, I'm going to lose data because it's going to try to go back before look at rematerialize the data, it's not going to be there, and it's going to lose that data. So, but yeah, it's not going to. Other than that, right? Like you have to make sure that the data is available, but it's not going to inherit naturally the policies of its underlying objects. All right. Any other questions? We're back here. All right. Cool. So we spoke about Timescale having a familiar and easy to use SQL interface. We like SQL. We know SQL. It's great. It comes batteries included. We get the job scheduler. We get all of these nice time series specific functions. We get great documentation. So far, it's scaled very nicely. Ask me in a few months from now if I still feel this way, but so far, so good. We talked a little bit about some of the fundamentals, right? We talked about hypertables are the fundamental building block of timescale. Continuous aggregates are like a special case of a mix between a view and a materialized view that builds on top of a hypertable. And we talked a little bit about some of the policies that you can enact, like refresh policies, compression, and data retention. So that's all. Please feel free to reach out if you have any questions or want to chat or come up later. Yeah.
So when it refreshes under the hood, does it always refresh the whole map view, the whole map view like it normally does, or does it know that it's append only and somehow only know to augment the new rows?
That's a good question. I believe that it refreshes the entire range, but. Oh, I'm sorry. Yeah, let me repeat the question. The question was, does it know that it's append only and it's going to only refresh the newer data, or is it going to refresh the whole range? One thing to add is it's not append only. It will work like a normal table. The reason I said it is not a great use case for something where you're constantly changing values or doing transactions within a time series is because like you can't do some of these things on compressed data. You can't do some of these things on right there, like continuous aggregates that may have run on it. So if you are, it's not that you can't do it. It's that it's going to be painful if that's a common query practice. To your question, though, will it refresh the entire range, or will it refresh the range that you've specified in your policy? If you know, hey, I'm not touching anything. Like I only need data to refresh the last hour or the last day or whatever, you can specify that, right? So you have control over that.
So, but it actually will
rematerialize, yeah.
But I mean, just the new batch of rows.
It will rematerialize that entire range.
On the basis just of the new data.
No, I think it'll rerun that entire continuous aggregate query, right? So it'll just like a materialized view will refresh the whole thing. Yeah. Yes.
Right. So when you did the continuous aggregation,
Mm-hmm.
right? You had your demo of it.
Yeah.
I gather that was specific to timescale and it wasn't available in regular Postgres.
Sure.
But is it actually unique? Like, did they come up with the concept at timescale? Because I'm pretty sure I can think of applications that are not in time series data.
Oh yeah. What do you mean? Like that? Yeah. I mean, no. Timescale, I would not say invented time series, and there are other excellent databases. Oh, continuous aggregations? I don't know. Is that their thing?
So I would say these have existed for a long time. They put a nice wrapper or a friendly kind of like API in SQL around it. The other thing that I think is interesting about this, no. The other thing I think that's interesting about this is Timescale does something to fill a gap. We have a need to do this like view over materialized view with the union, and some people are doing that hand rolled. they came along and kind of automated it. Postgres also has iterated on that way they do partitioning and some other things there. So like this kind of has come back to the community. Like, what should the semantics be? How do we think about time bucketing? All of that kind of stuff. But like the time buckets and like all the nice functions and stuff, those all come from Timescale.
Thanks.
Yeah. John.
Is everything UTC, or does it like?
It supports whatever you want it to be. Of course, why would you not do UTC?
People do it.
What?
I don't know why.
It's crazy. No. Yeah.
Do the policies like include any kind of self-defined error detection functions, or like define what you want to call as an exception, or you just do that outside of the database?
That's a good question. The policy, no. I do believe we're going to now go Google things. I think they have TimescaleDB. I think it's in the toolkit. They may have an anomaly detection thing inside their toolkit, which I talked about is sort of like a library of additional functions that's sort of like a plugin to the plugin or additional tooling. I feel like I've seen things like that. I've not explored it. I don't know. I can't speak to it in terms of like anomaly detection. Sorry, the question was, is there anomaly detection built into the continuous aggregate policy? And the answer is, I don't know. Yeah.
What intervals do you most commonly use in your workflow?
What intervals do I most commonly use?
Yeah, minute, 30 seconds, hour.
If I told you, I'd have to kill you.
Well, I'm
No.
on live, so
I'm kidding. No. No, I think I joke, but it depends on the use case, obviously, right? Like some use cases where data doesn't refresh very often, like we may have something that refreshes like daily, right? So then why should we refresh it every hour? Something that refreshes every second, right? We may want to aggregate that more frequently. So I would say it's hard to say that there's like a hard and fast rule on like what my most common policy settings are. And I would say that we do most of them sort of automated, so I'm not even sure. Yeah.
What are the trade-offs on the compression? Like, why don't you just compress everything? Well, there's got to be some downside, right?
Yeah, absolutely. Why not compress everything? So, like I said, you do lose. It is kind of a pain if you have to make changes. So, we generally, if we're onboarding, a new time series or something, out of the box, don't turn on compression. We may change that, but right now we leave it off because we foresee that we're going to have to drop something and backfill, and once you've turned on compression, it makes that a lot harder, especially as your data grows, right? Like now your compression, to decompress something will be take a lot of space, and then to recompress it. So yeah, it is an option to turn it on by default, but I think the downside would be that you lose some of the ability to make transactions or change your data.
I'll ask a follow-up. If you're a continuous aggregate, let's say you do it by month, you have January, February, March, April, June, and now you have new data inserted in March. When do you get to see that new data reflected in the continuous aggregate?
I'm sorry, you have your continuous aggregate, you put it back at the beginning. I missed the months.
So let's say it's now June.
Okay.
You have 5 new rows of data, or 100 new rows of data with a March timestamp.
How
does
okay.
that affect the average for March? At what point does it actually get included?
Yeah, that's actually a great question. That's one of the reasons that you might want to not turn on compression, right? Because otherwise it's hard. But yeah, if your data is before your continuous aggregate and it misses your continuous aggregate refresh policy, unless your policy is large enough that it goes back, it won't pick it up, right? So you would have to either you could manually kick off a refresh of that time period if you knew it were there, or maybe if periodically things sneak in that you don't know about. One, maybe this is not for you. Two, maybe you'll have like a longer policy that runs like, I don't know, once a month or something, right? I don't know what would make sense for your for your use case, but. Yeah.
Support for regular notebooks, like business day logic, that sort of thing?
Business Day Logic, I believe, is built into one of the toolkits. There is like a time bucket business day thing, I think. Don't quote me.
See if there's any virtual ones. When you're creating the hypertable,
Mhm.
can you segment on multiple columns besides time or only one column?
Yeah, you can. So time is your ordering column, and then you can give. I'm pretty sure you can give multiple segments. You can definitely. I'm pretty sure you can give multiple segments. Multiple columns to segment on. I would have to look it up. I wouldn't swear to it, but I think so.
Anything else in the room? Last chance. Anyone else? You might have. Let me see if there's anything else from the virtual people. No, not all. Just some other things. All right. Someone did ask this. dbeaver using that compared to VS Code, which has nothing to do with timescale, but.
dbeaver versus VS Code.
Yeah, for writing SQL queries.
I don't use either. Obviously, as you can see from my dbeaver expertise here. So I don't use. I can't answer that. I don't know.
Postico or?
Huh?
Postico? Postico, the like line, the like.
Oh, the ID.
Postico, yeah.
That's okay. We have a shout out here for Postico
Yeah.
in the room.
Cool. Last chance for an in-person question before we wrap up.
All right.
Okay.
Thanks for having me.
Thank you very much. Everyone, give a round of applause.
Thank you. So you too, if you come to a meetup enough times, you'll be forced to give a talk. So thank you very much for giving this talk after all these years.
Thank you.
Before we head out, just a few reminders. Remember, there is meetup scheduled for the next few months. We'll announce them through the Meetup mailing list. If you found this event other than through Meetup or from your boss, let us know where you found it, because we're always trying to find out how we reach different people, because it's a big group of people, and you can see the crowd changes depending on the topic. We've had a talk about Formula E, I think Formula E race cars. There's a totally different group of people come out for the pharma talks, for the finance talks. So it's really cool to see, there's always a core group of people who are always here, then people who come for different types of talks. If there are topics you want to know, come let us know. We'll find people for those topics. Again, volunteer yourself to speak or someone else. The R and Friends in Government Conference is in October at rstats.ai/gov. Sign up for it there with the discount code nyhackr, and learn more about the meetup and previous talks at nyhackr.org. And I forgot to announce beforehand, we always go to the bar afterwards. Again, if you don't drink alcohol, have a soda or a water or a juice, or just stand there and have fun chatting with people. All right? So we're all going to go to the Half Pint. Who knows where the Half Pint is? You, Paul? Come on, you know where it is. All right, you know where it is though. George is back there. George, so find someone who raised their hand. We'll lead you to the Half Pint. Otherwise, we'll see you next month. We'll send out a meetup blast in a little bit. Thank you to George for all your work helping this happen. And thank you, Michael, for that great talk. All right, see you next month, folks.